Here we go. All right, so today, April 21st, 2025. This is a quick review of what we talked about last week with programmatically accessing metadata. There's a lot of different ways. Some of the things that were highlighted by Daniel and Andy were a little different than what I had. What I had was something called a metadata object. So there are objects out there called metadata objects. And so those metadata objects can be accessed using access constraints, descriptions. It's probably about 7 or 8 of these things because a lot of times when we go to ArcGIS Online, do we want to look at all 410 elements? No, we definitely do not. So we sign into ArcGIS Online. My big focus is on the software, and probably I should focus a little bit more on this. But when you all sign into ArcGIS Online, it looks something like this, right? Oh, I'm just making sure. Okay. All right. And so I've got my content right here, and this is all the content that I've created because we're going to look at one of my projects here in a little bit, but I'm doing a quick capture project right here. I haven't created any metadata for this, but you can see usage, and I can click on metadata right here. You can see some of the metadata about this for this particular project. In particular, I want to look at the web map feature layer right here. And so when we look at this GPS, because we're going to look at facets of this GPS project here, I have something called an instant app. I have a quick capture project, which is part of a web map, which is composed of a feature layer, which is basically a feature class, which I used to call shapefiles and coverages a long, long time ago. And I sometimes call them layers, even though layers are slightly different. But basically, this feature layer is either points, lines, and polygons that are superimposed on a map that can be shown with other points, lines, polygons, rasters, images, all these other kind of geospatially registered objects as well. But they're contained within a web map, and these are part of a quick capture project because we're going to focus on this in our field mapping class. So last year, I think I've focused on something called the field collector. Now I want to talk about something called Survey 123 and quick capture because I've got this project that I just can't take my eyes off of. And I'm going to talk about it a little bit since we're talking about data science and geostatistics and all those other good things. But this is kind of all the, I don't want to use the word junk, but this is kind of all the, all the junk that kind of sits there amongst my stuff. But when I click on the feature service right here, I can click on metadata and it tells me all about this. It looks like there's like a brand new metadata editor, right? Okay. Data. Hold on. Overview. Okay, when I look at the overview here, it looks, okay, when I look at the overview, this is the information sitting there from the metadata. And now I have the metadata that I can go type in stuff here. In addition, I believe I can import metadata. That's a question, good. And I can import metadata, but like some of the other things we talk about, this is all the metadata. This is essential metadata. Even then, now the essential metadata is a lot, but this is what it looks like online. And this online metadata is getting more and more and more robust. So I can type in, statement purpose, the abstract like A, B, C, D here. I can click the save button and it should be reflected sitting right here because a lot of times when we start to look at data that isn't even ours that we can't go edit, we'll be able to see this description, layers, terms of use, any comments that are added to this for people who have access to this using ArcGIS Online. So this, this accessibility is really important here. So I think people have done some really good jobs about being able to pull this information, count it, and go and update these. And I think I showed some descriptions or showed some examples where I went and wrote this to CSV files. We talked about the idea of metadata. But there's a whole field of metadata that you can do that's widely underreported, underutilized because people don't want to do stuff on information about information, and that's kind of where I found my, dissertation, and I just filed for a grant, $650,000 or something like that. So maybe someone will give me $650,000 to go do metadata stuff, pay someone $75,000 a year to do it for me, some postdoc or master's student or something where that would be their living, all that other good stuff. And I get credit and they go work with, the community and everyone else, and they would work with the state, and so some of the things in our graduate student meeting, you go and work with person at the NCGICC, North Carolina Geographic Information Coordinating Council, where you go and, hey, we need new metadata training. Your metadata training stinks. What do you want? Hey, we're going to work with you guys. What kind of metadata do you want? Can we update it? NC1 map, all these other good things. We have PhD students and master's students right now. They go and work with county health directors. There's someone, I don't know if Gene is with us right now. He goes and works with county health directors and speaks to them, and I do absolutely nothing, like nothing. And he goes and does this, and that's good practice. Dealing with me or dealing with professors or any of those things are nothing than dealing with people who work out in the field, especially some of these rural areas where people are really underinformed, have very little data literacy, minimal data understanding, and really trying to equip these people with maps that can, for people age 9 to 90 with various levels of understanding about their tangible and intangible community. And these people are on the ground, educating people about health clinics, COVID rates, methamphetamine, opioid, all these other things here, and try to make them understandable. And that's really good practice. That's really, really good practice. And that's kind of a sink or swim, effort, to be honest with you. So this is what we talked about last week. I also kind of highlighted some funding opportunities. I was kind of joking with Kimberly or Mary or someone like that before class, where that if you got to rely on me for funding, that's hit or miss. Because you know who I look out for first? I look out for me first. Me first. And then, all right, we work with students, Well, I kind of joke like, students are 1A. I'm kind of real close 1B, real close, Depends on, but if you want to go out and get yourself some external funding here, because, the funding that I give, I try to spread it out as much between people as I can, but who wants more? Oh, I think we all do, and so there's some really good sites here. I think I had one of them here, Eisenhower Scholarships or Eisenhower Fellowships. One of my students got this a few years ago, and it was something like, $30,000 over 2 years, and I was paying her just $1,500 a month. So she really kind of did pretty well with this, scholarship and fellowship, and required her to present. That might be really applicable for some of the fire response and other things like that as well. So Eisenhower Scholarships, Parks and Rec, all those other things here as well. So we've got those. Well, today was a big day in the sports world. What was it? Did anyone know what happened today? Sports world. Boston Marathon was today. So I ran it 6 years ago, so you can see it right here. Yeah, I ran it 6 years ago. I'm talking about it because I ran, and this is what my little GPS told me. So you can see the course, and I ran with this little guy right here. You can see my pace here. I had a little bathroom break right there, about mile 2 right there. That's why my pace went down. And you can see the elevation. So this thing keeps X, Y, and Z. Or elevation. It doesn't keep X, Y, and Z very well, but it keeps X, Y, and Z. You can see my pace. My pace kind of went down here, and eventually it just went. And then you can see the elevation. They have something there called Heart Rate Hill. So you can see where my pace went really, had a rough time there. But I say that because we're going to talk a little bit about, because we don't have too much planned today, except for looking at some of the deep learning modules. And I tried running these on this computer here, and they didn't work all that well. And so I'm going to kind of do a quick demo. And if you want to start like downloading them now from the modules, do that, because they're like 2 gigs of images that I collected. So they get really big really quickly. But I'll show you some of the deep learning modules that were able to work on my computer. because I ran them on my other computer. But the thing about Boston Marathon is that it's on Monday. Like we all went to work today, right?
Yeah.
So what's going on? Like what happened? What happened 250 years ago in Boston?
Boston Tea Party?
Shot heard around the world. What's that? Beginning of the revolution. So instead of like North Carolina, we have a state holiday on Friday for Good Friday. They call it Patriots Day. So the first day, or like basically the shot or whatever that started the American Revolution 250 years ago today or this week or whatever. So they have Monday off. Boston Red Sox have a game at 11 o'clock. So it's pretty fun. My wife went to it, but this was the marathon. It was pretty fun. I kind of joked with my kids real quick. And on the way up, we stopped in this town called Newport. So we drove from North Carolina to Newport. Anyone ever hear of Newport before? Anyone ever been there? Really pretty. I was born there, but I don't really remember living there because my parents, but it's got all these like famous mansions here. So it's got all these like famous mansions that where like the Vanderbilts and the Astors and all those other people kind of went and had like their summer homes and stuff like that. So it's kind of like, has anyone ever been to the Biltmore?
Yes.
Yeah, Biltmore. So you got a bunch of Biltmores basically in this area here. And this one is called the Breakers. This was the first one we went to, but we went up there. I didn't want to walk around too much here, but I'll show something really, really funny here. I was sending it to my kids here. I was sending it to my wife. But we went and toured these things, because I didn't want to walk too much before the marathon, because the marathon's on a Monday. We went and toured all these things. But this is me at the marathon. One of my friends lived up there, so he got that's me right. I wasn't doing so hot. But we went to a place called the Marble House, and that's one of the boys there. He's not doing too well. Like not me. So this was the first picture here. He's doing good. He's not doing too well. What do you think's gonna happen? And then boom, then he goes, pukes all over his sister. Puked all over the ground. That's like it's all right there. That wasn't fun. That's my friend right there and his kids but it was pretty neat right there. Real historical area, but I kind of use that as an aside because I've got this GPS unit that I'll walk around with. And part of our field mapping class that we're going to do is how do you create, and it ties into data science and it also ties into geostats because I went out just to the front of the building right here, right out the door there, and I walked about 300-meter square right out there using this really high quality GPS unit, real high quality GPS unit. And I created this in something called quick capture because most of the time when we work with data, where do you get it? I give it to you. Here's the trail data, here's the road data. Here, at some point in time, you're going to need to go out and make your own data. So I went and just walked this little course right here. And what I want to do is compare it to my iPhone and compare it to my little watch here to see how basically good it was. And this is kind of getting into our wheelhouse where we go and create data. Now, when I right mouse click and open up the attribute table, I had to do a little bit of GIS magic. These are all the attributes that it creates. I created something called a streaming service or streaming. So instead of me walking, collecting a point, walking, I just set it to be streaming. So as I walk every 5 meters, it pops a point, pops a point, pops a point. And so eventually what it's going to do is I can just go and connect those points, sort those, connect those points to make a point to line feature and close the loop essentially. And so what I did here, these are all the attributes that it collects as I didn't make this stuff up. It's collecting these things. And what we're gonna do next is look at what the iPhone has, look at what my other GPS has, and then go and how do we compare the differences? Because that's what we're gonna do in field mapping. Hopefully we'll get some ideas with generating just large data sets and figuring out how to make sense of these. So I've got this here. These are all the attributes, the speed, direction of travel. What's this direction of travel mean? What is this 170, 180, 160, 160, 160? What's direction? So what direction am I walking with 180, 160, 160? South, right? So you can see right here, the first, and I walked in this direction here. Walked here, went here, went here. So I did a loop starting south. Yeah, did a loop starting south. And also depends on like what direction this thing's pointing and all that kind of funky stuff here. The compass reading, external source, GNSS, Global Navigation Satellite System. Yeah, a little different these days. I like using the word GPS, so I'm probably never going to go to, just like feature layers. Yeah, I'm always going to use feature class or shapefile or whatever. We've got vertical accuracy, horizontal accuracy. This basically means how far off it could potentially be based on the coverage of the satellites. And Andy, if you got anything to add in, let us know, because I know you did this for a living, right?
I think GPS is expensive or something like that.
Yeah.
But as new ones are sent out, like general name is GNSS.
Okay.
You're talking about the ones that US sent out.
Okay. All right. What Andy said, GNSS. GPS is a subset of GNSS. So GNSS is a whole bunch of satellites. GPS is what, 30 satellites, 25 satellites sent out, 24 satellites sent out by the US. GNSS is it's probably a little bit bigger, a lot more. That help global navigation satellite system. All right, what I've got here, vertical accuracy, latitude, longitude. That's pretty cool, right? Altitude. I believe this is in meters. I'm pretty sure this is in meters. P dot, H dot, V dot. This is positional dilution of position, horizontal dilution of position, vertical dilution of position, fixed type, number of satellites that it got hold of, fixed time. So you can see this one right here. I collected at 3:29 and 22 seconds, 3:29 and 26 seconds, 3:29 and 30 seconds. I walked out in the morning, so I assume this is at GMT, Greenwich Mean Time, which is 5 hours ahead of us right now. Is that right? Is Greenwich Mean Time 5 hours ahead? That sounds about right. Average horizontal accuracy, average vertical accuracy, global ID. You can see who created it, T Mulroon _ this is my username, so that this can be shared with everyone else right here. And then this is the edit date. Now, the one thing about this, when you start creating these lines, notice the edit dates on all these are kind of the same. So if you start to say, hey, let me make a line, go in the order by the edit date or the object ID, it's going to be a little different. Now we kind of circle back here and we look at these object IDs. These object IDs don't go in order because this is the first one. This is the second one. This is the third one. Look at this. This is object ID number 1, but I didn't jump all the way here and then start up at the top again. Why is that? Or does anyone have any ideas why that might be? This is my guess too. My guess is that they're probably getting loaded to the cloud in clusters, not one at a time, but probably getting loaded to the cloud in batches. So their creation ID is all the same while their streaming is also being collected. Does that sound smart? Okay, that's what I'm gonna go with right there. Okay, that's why. Okay, that would be my best guess. Yeah, that'd be my best guess here. And so I sorted these based on the fixed date and fixed time here. The actual time that it was created, 17, 26, 30, 34, 38. And I probably walked for a couple of minutes right here. Now, the interesting thing we want to do next is, this is with my iPhone. Now, the app to connect to this is just goes through this, which is kind of funny. And so you got to make sure as you're walking along, you better say, hey, my receiver is this guy and not this guy, because all it does is create a Bluetooth connection with it, and and it just shows up here in the little quick capture app, and all I want to do is just capture points. And we'll also do the same thing with survey 1, 2, 3, and then if you want to do something later with field maps, it'll do that. But this is what my iPhone collected. So iPhone did the same exact thing. iPhone did the same exact thing, right mouse click here, open attribute table, you can see here. But look at some of these horizontal accuracies, they're off. So it's a little different right here. All right, next. Now it's got the same exact thing. It's got the latitude, the longitude. Now the next one, and what I can do here in my little GIS, because this is where a lot of people kind of get lost, is that I want to create GIS data. My little Boston Marathon course, I can click download, and I can download this into something called a GPX file. So this is my Boston Marathon course, GPX file, and this is going to create a type of, to me, it's a type of XML file, but it's just a tagged file that gives me very first date. It's got my track point. This is my heart rate. This is my cadence. This is my latitude and longitude. This is my elevation, time, and it's collected probably thousands of points for me here. But it's got the lat, the long, the elevation, and if it knows the lat, the long, and the time, it can calculate the distance between me and somewhere else, and just do distance equals rate times time to figure out my rate, my distance, and all those other good things, because all it's doing is just a delta or a difference on the time. And so, believe it or not, ArcGIS Pro has ways to bring this into GIS. How do I look for these things? It's really easy. I go to analysis, I go to tools, I start typing in GPX, and look what shows up, GPX to features. So I can just convert these to features too. Now this is what my GPS looks like. Because what we're going to do for the field mapping class is basically, we're going to go hike a trail over in Hillsborough at a state park and see which one of these is best. Now, when we open up the attribute table on this, and I already have a journal for it, so I'm so excited about that. Now, when we have this though, what's the problem here? Got a name, description, time, elevation, and at the time, it didn't have the latitude and longitude. How do I add the latitude and longitude? X, Y, exactly. So I can create a column called X and Y. I can right mouse click and do something called calculate geometry. And so it'll give me, and this is what I did exactly. Calculated the X, calculated the Y. And so now I've got X, Y here. X, Y here. Now, the first time I ran it, I switched the X and the Y. I said the latitude was the X, longitude was the Y, and got goofy results there. And so, and that's the good thing about it. Good problem solver. Now, my question is that for us data scientists, because we got a whole bunch of points here. We've got 51 points here. We got 61 points here. We got 61 points here, because all I did was sample every 5 meters. So 61 times 5 is about 300 meters or whatever here. And so you can see this one's a little bit more, and then you'll kind of see these here. But how do I measure which one's the best? What are some good descriptive statistics? What are some good descriptive statistics to measure the difference between the orange versus the green versus the black? Which one's the best? I hate to use that word, but how do we assess and evaluate? What are some, just assess? What's that? Well, you're thinking way too much. Let's go to like week 2 of geostats. Was week what?
So it was an average or mean?
The average mean, not even there. What's the length of the orange versus the length of the green versus the length of the black? Because right, because which one is really, because we can. Yeah, the black one's going to be much longer than the orange, which is probably going to be a little bit longer than the green, because these greens are probably just sampled every so often. I wasn't slowing down and moving forward. And so what I did here, I eventually brought these into Excel. So I brought them into Excel. Let me move these folks over a little bit, because I want to figure out, hey, what's the cumulative length of these? Cumulative length of these. Now now you gotta start, this is where you start earning your big bucks. What is the distance between the first point and the second point, and the second point and the third point? So I created a couple of columns right here that said, what's the distance between the first and the second and the third, and the third and the fourth? As I'm going along, I'm also adding these up. How do you calculate? Do I have anything here that gives me location so I could calculate the distance between these? Because I had trouble figuring this out, because I was trying to like do some fancy ArcGIS Pro function, and I finally said, let me just put this into Excel and see what Excel gives me, because there wasn't a lot of ArcGIS solutions to do like find length, vertices, pick apart. Yeah, I'm kind of looking at some people. You guys have any ideas for this?
That's calculate distance here or in ArcGIS Pro.
Well, any ideas in ArcGIS Pro?
Yes, Pro. Here also there's like a formula.
Yes, I know that. Yes, I was waiting to. What about, what's your ArcGIS Pro solution?
Solution to fit a line.
That's what I did.
Plates. There's a function for length of line.
Yeah, I did that. Yeah, I made the line. Watch, that's what I did. Okay, and Andy's getting a little warmer here. I created, here's my little line right here, right? How many features is this line? It's one feature. And I can calculate that length, right? I can calculate that length right there. It's just one feature. It's composed of 60 vertices, but that's internally stored.
You can break the vertices so it calculates the length.
How do you do that? Because if we break the vertices, I already broke the vertices. Isn't that what this is?
Yes. But you can break right now it's just one line.
Yeah.
But you can break it from one feature to 9 features.
How do you do that?
I just need to look. I'm sure there's a tool.
I'm sure there, yeah, I couldn't find one in the hour I was looking. So, yeah, so we could break it. It's probably something like Split or something like that, where we get into data editor. One of the things gave me some topology tools, networking tools, and I was like, I don't want to learn any new stuff. And so, like Andy alluded to, there's a big old formula. If I've got a latitude and a longitude, this is the way I can calculate the distance. Boom. Do you think I thought of that myself? It's sitting out there on the cyber web for us to calculate. All it's doing is, what's the 6371 times 1000 represent? What is that number? What's so special about that number?
The radius of the Earth.
Radius of the Earth. In what units?
Kilometers.
And this one's in meters, times 1000, but in kilometers, but I multiply it times 1000, so meters. So that 4.5568943, does that make sense? Why? What did I set to be the distance between each point? Not 5 kilometers. We're just walking out front, 5 meters. So I'm just walking along every 17 feet. It collects a point. That makes sense right there. 47505, 4.9, 4.65. Yeah. And then in Excel, what am I doing? I'm just adding these 2 columns and then these 2 columns, the next 2 columns. So I get a cumulative distance. So for the first one, the total length is 280 meters. And I bet if I were to run what Andy suggested there and convert those geographic coordinates, I'm probably going to get something really, really close to this. Now I do it with my iPhone.
Hey, Mr. Moroni.
Yes.
Is that like doing like a linear interpolation?
No, I'm not doing any I'm not doing any interpolation whatsoever.
I mean, like a kind of like a rule of 3.
An
There's
average?
yeah, kind of like similar. I've seen some engineers doing it kind of like that way.
Yeah.
I was just wondering if you have tried it with like any other types of like maybe like a polygon or like something that is not really like like a perfect line, if that makes sense, with
No, I
curves.
have not done that yet.
Okay.
We did that with our stuff when we were rolling averages or moving averages, but here, no, because I'm just looking at it from one point to the next, and I'm not an engineer, so my dad
Okay.
is, and we
Okay,
would
I was just wondering, because it seemed something like I was doing the other day. So I think it was really interesting. But
okay.
yeah.
Yeah, to me, we're going from one point to the next, so if they're all quote unquote off, they're all gonna be off. But for the iPhone, which was kind of lot, kind of moving around, it was 302. And then for the Garmin, my phone one, it was 284. So, and then what we're hoping for classes, someone's got a Samsung. So we got 4 different kind of collections. So what's going to be the best? What's going to be the best thing to collect with? Are there any other phones out there like Google phone? I don't even know the phones. I barely have a knife, but that we can install something on and then go collect it while we're talking. Yeah,
Is the phone or the
probably a combination of both, all of the above. But, when we're collecting, and it's probably location as well, so combined with all 3. So when we're out there, but, we're overestimating almost 10% with the iPhone, so your, trails or whatever are going to be 10% longer. Now, what's the other thing that we can look at? We got X and Y, but what else? Up and down, Z's. Because the interesting thing with my watch is we go from 93.8 to 102, even though I start and end in the same exact place. Okay, and that's some of the problems with, running with these is that it's pretty good XY. It's not very good elevation because in the morning I run a point to point course, but I don't start and end at the same elevation. Or my watch tells me I don't end at the same elevation. So some other things. What's the difference between the highest and lowest value called in stats? Max, min, range. We got range. Oh, we got the range of values here. What do we have? We have max and min here. I'm pretty sure it's somewhere here. Elevation, but look at this altitude here. 118 versus 125. And then this is going to be 138 versus 120. Look how varying, it's almost like 90, 100-foot difference in altitudes between this and this. Really interesting. And what I started to do with the geode was, I make this little point-to-point course here. I just walk around a little square on the front where there's maybe 5-foot elevation change across it, and look at my elevation change here. It's probably, probably looks pretty good. It's probably a little lower down at the far side of the building versus here, but this is some elevation change that we have here. And so we can superimpose these on top of each other. So we can look at some real basic descriptive statistics to figure out which one is going to be different, statistically different. But look what we're doing. And the one thing we don't realize is that we're always producing data, like always. My little phone thing here, my little Garmin here, I'm always producing data. You're always producing data. You're always producing really interesting data that we can do some neat things in statistically, but also spatially. And Andy's got some really good ideas for, hey, can we go and connect these and then go back and decompose these back into the individual vertices from which we started, but add the distance component to it as well. So I can go and change the projection because these right now are being projected right here. This is the projection which we call geographic coordinate, some latitude. So that conversion in Excel isn't necessarily exact because the radius of the Earth is going to be a little higher at the equator versus the pole. So it's just the average radius of the Earth, which is 6,371,000 meters or about 4,000 miles. That makes sense, right? 4,000, 2 pi r. 8,000 times pi is about 24,000. What's the circumference of the Earth? 24,000 miles. How wide is each time zone at the equator? About 1,000 miles. And they get smaller and smaller, smaller, proportional to the cosine of the latitude. You know, so at like 60 degrees, it's half. 30 degrees, it's what, 86%, square root of 2, square root of 3 over 2, right? Square root of 3 over 2. And then it gets kind of really exaggerated as you get towards the poles.
But it was- I think you were right about the tool. It's called split line hypothesis.
What's that?
The tool.
No, just say you're right again. I'm sorry.
Right.
What's that?
Yeah.
Okay. Oh, the third time is even better. What was the name of the tool? I was just so caught up in you saying that you're right. So
It's called split line hypothesis.
yes, that thing. Yes, but it but that's an editor tool, and so you know, so I'm not sure how much different it's going to be. And guess what? That might be a whole nother project with, hey, is the split line tool or ArcGIS Pro Editor tools as good a way of measuring distance as other tools? You got a whole nother paper sitting there ready to go with how do we decompose lines? How do we create lines? Because one of the things I would like to do is submit this to like not anything GIS-y, but like Parks and Recreation. And we work with some partners over in our college called KRI, Kinesiology and Recreation Administration. And I'm pretty sure we have a couple of PhD students that came from there. Is that right? Yes, we've got one. Philip came from there, and meaning like, hey, I'm out collecting data using my phone versus my watch versus my GPS, which one's the best? And then how do we assess and evaluate these differences really in layman's languages here, which, you know, we're not talking about interpolation or IDWs or splining or any of that other stuff like the total length. We know what the total length is. You know, we know what the elevation changes. Let's look at a nice pretty map of this versus this versus this. Maybe if we want to, we can put these profiles next to each other and do some type of Poisson calculation versus those. Remember that Poisson distribution, even though these won't display Poisson distributions, but hey, let's see how these profiles look against each other so we can see these differences. So we can summarize, hey, you know, if you're working with Garmin, they're not good for elevation, but they compare pretty well to this because I don't think a lot of people have $3,000 to go spend on one of these things here, you know, to go spend on one of these things. Big bucks. Okay, big bucks for these where, you know, maybe this thing is just, you know, good enough, but who knows? Who knows? But I like this idea, and us being in data science, we, you know, in, you know, 3 minutes of walking, I've gone in 3 minutes of walking, I went and created 3 Excel spreadsheets worth of data. I started doing some fancy stuff right here with arc cosine of the radians. What's all this radian stuff? You guys remember this from like algebra 3? It's conversion. What a circle is 2 pi radians or something like that. Why do they use radians? You know why, Andy?
And do math transformations to a normal number.
Okay. Yeah, I don't know. Like, I don't know why we had radians. I've grown up with radians. I don't know why. Just tell me the degrees. I know the degrees, you know. And so we convert these to radians, and then, but these are just nice big fancy formulas that I just calculated, tweaked the columns a little bit, and then calculated these, and they made sense. Now, the funny thing was, when I did it for the iPhone, I switched the latitude and longitude, and I saw it was like 100 meters instead of 300 meters. So I was like, something's wrong here. And then once I switched them back, it made a little bit more sense. And those are kind of where you start making your big bucks with these things here. Yeah.
The lat and long that you got, were you giving the X and Y from home, and that's what you utilize?
Yes. Now, the question was, for the phone, to give me the X and Y, yes. For the phone, it gave me the X and Y because the actual, I used Quick Capture, application called Quick Capture, which lets you capture features quickly, for lack of a better term. I set it up using a web browser, creating points, and then I would just, hey, this is the first trail. I'm just going to kind of, they're all going to be part of the same data set, but I say, hey, I walked these from 11 to 11:15. That's going to be one. Oh, this is from 11:20 to 11:25. This is number two. I'm sure I could create separate features or whatever, but at the end of the day, I knew what I was doing. But eventually, if we go out in the field, like, hey, you're going to be Will's iPhone trail, and then, you know, David's Samsung trail 1, and so you're going to be collecting a different set of points from his, and then maybe we can all put them together. And that's where the data management component gets, really, tricky isn't the right word, but you got to figure it out. You got to figure it out here. You got to figure it out here. So that's pretty cool. I'm kind of excited, you know, to me, it's kind of exciting. You're making, you know, making data that's going to be useful to Parks and Rec or whatever, and the cross application of these things. And, you know, Andy just thought of something, you know, here, like, hey, I'm going to compare doing these calculations in Excel versus doing these all in topological editors within ArcGIS Pro. Is there a difference? I bet you there's going to be a difference in them, right? So I'm kind of excited about those. Okay. The last week of data we're looking at here is I started working with a student, and we're going to do a little bit of AI/ML stuff here. I don't want to make it brief. I don't want to use the word brief, but my computer does not like running it because it's so weak. I just bought this computer. I spent like $3,000. I didn't spend it. My grant spent $3,000 on this computer, you know. But I also bought another computer that ran these cars and other things really, really nicely and neatly, And so the whole idea, like AI and ML, it's been around since the 50s. Like, I hate to say it. Now, what's this new revolution of AI that people are talking about? It's what we call generative AI. Like, it's starting to make stuff for us to elucidate patterns or whatever. But what we're going to look at here are some imagery that one of my students collected, where I asked him to go collect drone imagery from this part of campus for a few different days, because what we're looking at here is for December 2023, January 2024, February 2024, where we're going to go see if we can pick out cars. Like, literally, can we detect cars? Because who wants to go and count all these cars? I don't want to. Okay? I definitely do not want to. And so we can create models. Now, what are some of the physical, and this is where we get into some of the AI/ML that I'm not super great with, but what are some of the physical properties of cars that differentiate it from anything else on this image? Length, size. So the height, the width, the size, you know, color, exactly. And so we can start to create models and say anything that looks like that kind of shape right there, it's going to be a car. This car right here, how's it going to know the difference? How about, is that a car right there? I don't know. Okay. I'm not sure on these. And we're going to run it a couple times here. I've got some imagery here, and I'm going to show us where we can get our models, because I'm going to talk about my next project that I want to do with AI/ML, or not. I just want to get credit for it while someone else does it. You know, all kidding aside, we got this really, you know, we got some good ideas here, but, and, you know, and all kidding aside, you realize this, the more you learn about GIS, the more you realize how much GIS is out there, how little that you really know. Anything with geoprocessing, what you can do to data, some of this, you know, hey, I'm going to create data, you know, all the data standards for the GPS, like that's my wheelhouse. Some of the stuff with metadata, I'm good, but you know, programming, the GPS stuff, everything else is gonna be, this is what we are. This is all right for the taking for you all to be the SME, subject matter expert someday. And so I ran a couple of these right here for the January 2024 data sitting right here. I went and found all of the cars. This is just for a really small area because it takes like forever to run these models right here. But just for this area right here, this is it, right? Come on. There we go. Okay. So for this little area right here, these are the cars that it detected, because we're going to go through and run this, and I'm going to show you where to find some of these models. And hopefully a couple of you have some ideas like, hey, you know, there's lots of other things out there that we can detect, because when we start to look at some of these models, like I'm only showing you one tool. There's tons of other models. You can train models and all these other things, which take, in some cases, like days to do. So the first time I ran it, I just ran a little subset here. You can see for January 2024, we have errors of omission and we have errors of what we call commission. And you can see definitely it missed one, right? You can see it definitely missed a car right here. What's different about this car right here than all the other cars that it's probably further from the bumper. Oh, the shade of it, I don't know. Yeah, it looks like a little more tilted or something, you know? Yeah, a little more at an angle. And those are all the things that you can train the model for. There's a lot of input parameters like patch values and all these other things that to be honest with you, didn't exist till about 10 years ago, which I don't know a lot about. Here's another one from February. Oh, we won't look at that one here. This one, February 2024 for a different image. It's slightly off, okay, because when we look at this one here, now, this is the entire parking lot. What do you notice about a lot of the cars that it's missing? Dark. This thing's got this little like racing stripe right there. So these cars look darker. And then you got this kind of truck thing going on here that's obviously dark. But I thought this was kind of neat here, even though it looks like it picked up this dark car, but it didn't pick up the other one. Yes.
It was running on people, it's not that.
It's picking up cars because we're going to look at some of the tools out there in the Living Atlas, and it also has parking spaces, which is probably going to use the same libraries, because when I was running the errors, I was running into the Python errors in this computer here, pulling up the same errors and it needed the same libraries. Something called Torch. Does that ring a bell, Daniel? PyTorch, yeah. Yeah, PyTorch. What's that do? And then Fast AI.
PyTorch is
Oh, okay. Oh, okay. Yeah. And there was one library needed called Tim M, and I'm like, that's not my username. It's like Tim Mo, you know. And it's like, what are they asking, talking to me? And then there was really a Python library needed called Tim M or TIMM. So I thought that was kind of interesting. So we can see these with the February 2024. This, you know, these are good, you know, estimations here. You can see out here on the street, it's trying to, you know, trying to pick them up here. You can see over here, you can see, because why do we have this junk over here? Why is this junk? Why do we have this junk here on the edge of the image? It's cutting off overlap, because basically what my student did is he went and flew a bunch of drone images, but if you're only doing overlaps with one or two images, the mathematics to make them all fit together, it's harder on the edge, as opposed to here where I have a drone image here, and here, and here, because what I like to do is try to fly with about 75% overlap. So here's your picture, you just go over, and then go over here, so you're getting overlap in 2 different dimensions. And me personally, I would like to take orthographic images or orthometric images straight down, but I also like to take at an angle, because then you can get the 3D, eventually get the 3D renderings in the point cloud. But someone like me always likes to take them straight down, because I like using these to measure distances. Not really for the aesthetic value of them, but for the, just for the map and the computational value of these. But there will be computational value in some of the 3D object as well. So this was a neat one that I ran right here. I thought that was pretty cool as well. And then let me see if I got this December 2023. And then I had one for December 2023. I was able to run it on my computer. And so this is one in December 2023. It gets a little goofy here, because you see it's got the cars, but it's got the, the bench here too. And then it's got this one here. It's got one of the plant beds that have been covered up, and so I assume it's kind of looking at color or shade or whatever, or whatever as well. And then going a little further south here, I think we get these cars here, but then we get some of this kind of junk right here. It's picking out that we can go and get rid of, and we could probably run an area of extent or something like run a environment just to look at these areas. And even interestingly, it kind of got the cars, the back of the parking lot, going back there. All right, the last one we'll look at here, and I'll show, and I was able to run this, was I was able to get trees from February 2024. And the neat thing about this is when I go to Esri Living Atlas. Now, Living Atlas is basically Esri provided data and resources. So when I go to my ArcGIS Pro, click on Map, Browse, I've got access to, I got my content. So all that stuff that you were looking at online, it's sitting right here. So this data that I just created, the trails or whatever it was, the survey trails, the Mulrooney GPS 2025. This is the NC County State Plan. I think this looks like the data layer that Andy updated. All this stuff sitting right there, like literally 507, just at the beginning when I was playing with the metadata, you can see where it's sitting there. And hopefully I've given everyone edit access to these as well. So everyone has edit access, Mulrooney points, example points, trails. I think I want to go do some stuff with Haw River trails and things like that, landmarks. So I can do these, but also ArcGIS Online, Living Atlas. So we've got tons of things here that are mainly created by Esri supported. So I can create something like income, and then it'll have low income census tracts, ACS, created by Esri demographics. So what does ACS stand for? What's that? Oh, American Community Survey. So it's kind of taking the place of the census data, because we don't want census data just every 10 years. So this is sample data collected here. So I can, look at these. I see who creates these. It's not like, Jimmy, creating the data and putting these out there. It's Esri demographics. So this is pretty reliable data that we can put out there instead of me going and downloading everything as well. So, but with the online version of this, I can type in car detection. And what I've got here are car detection in the United States, deep learning package by Esri Analytics. So these are things that I can bring into ArcGIS Pro. This is a deep learning model, is used to detect cars in high resolution drone and aerial imagery. It can be used for applications such as traffic management, analysis, parking lot utilization, which we're doing here. Urban planning, it's a proxy for delivering economic indicators using it, but it's got metadata sitting here for us. The input is 5 to 20 centimeter spatial resolution. What do you think what do you think the resolution of that drone imagery is? Is it better than 5 centimeters? It's actually better. I think it's like 2 centimeters. Really good. You can't read license plates. What is resolution based off of? How do I calculate resolution?
Pixels are in the.
How many pixels? What is that a function of? How high you're up and how good your camera is. And then we mesh them all together and bippity boppity boo, it comes up with a resolution. You know, and we could sample those out a little worse if you were like, hey, I really need 5. I don't want to have 1.14 centimeter resolution. Has an average precision of 0.81. It's been trained, but these are some of the things that you can go and download. And I can click right here and I can download this into something called a DLPK package and bring these right in. The other thing we'll look at, there's a lot of these models out there. I don't want to say a lot, but there's one in New Zealand. There's another picture of it. But I can type in the word detection. But look at some of the detection. We've got NOAA FMS fire detection. I assume these are wildfires. Smoke detection, tree detection, palm tree detection, car, thermal hotspots and fire activity. These are pretty neat. I can click on these and I can open, oh, these don't let you download these. Why don't they let you download some of these? What's that?
Where's it coming from?
Yeah, or money. Well, proprietary with some of these, or some of these, in some case with probably Esri and NOAA, they like, we don't want this downloadable. We don't want this to be on our, we don't want you making like life and death decisions using our model. And we've got precision or accuracy rates of 81%, and you're making decisions based on these. Because you notice it's still picking out like garbage cans and all these other things that are really kind of problematic. Car detection, ship detection, oil spill detection, from SAR. I assume this stands for SAR imagery. And if you were here with the folks from NASA, they are really good with imagery. SAR and Sentinel, that's like another language for them. To me, I just know Landsat and drone. That's about it. There's so many, platforms out there. And if you were here with those NASA folks, they like that's all they work with. That was one of their complaints, because their complaints to me was like, you guys do a lot of GIS. And I was like, yes, I know I do a lot of GIS. You probably need to do a little more remote sensing and working with imagery and all the imagery resources out there. And I said, yes, I'll tell Dr. Yang to go work with some more imagery, because I don't want to learn it any, but we've got ship detection, and we can use this automated identification system used for ship. Think about how useful this is. This uses high resolution 3-band RGB resolution of 30 centimeters. Lots of these data available out there. But look at these neat things that you can go and get, and download, and utilize some of these. There's order to these. Parking spot detection, insulator defect detection, like just building change. And there's a lot more of these out there. Now, one of the things, solar panels, cloud masks, rooftops, and one of the first and swimming pools, one of the first applications I saw for these was rooftops and driveways. Why is rooftops and driveways so important to like local municipalities, detecting them? Because we had a project maybe right when I started here where someone was out digitizing all the rooftops and the driveways. Reflectance, yeah. What about a more practical application? Proximities. What's on your water bill? When you pay your water bill, what's on your water bill? What's that little bottom? I used to live in the city of Greensboro. You pay a little extra fee for like sewer fee. What's that based on? What is that what's that little sewer fee based on? How much you contribute to the sewer? What is that based on? No? Impermeable surface. Yes, so you have a yard right there. Everything that hits a permeable surface, where's it go? Into the groundwater. Anything that hits an impermeable surface, where's it go? It goes into the sewers. Yeah, so all the drainage. So you have more roof space and driveway space, guess what? You're gonna be paying a little bit more. Now, those fees were like tiered, like $1.20, $2.40, and $3.60. But some GIS person, 15 years ago, some tech, that was their whole job, was just go and digitizing the outlines of all the driveways and stuff. That was me a long time ago. I was out digitizing homes and things like that. Long time ago.
They still do.
Oh, they still do. Juan says that. All right. They still do. Okay. So we've got some of these here, parking lot classifications, some really neat things here. I'm going to show one example. I'm going to show my idea, and then I'm going to finish for the night for everyone. And then after the break, I'll talk about the final for people who need to be here for the final, because there's a number of people who don't need to take the final. So, but I'll talk about that final. All right. So what we're going to do here, and I took notes of what I did, because my computer does not like, I don't say my computer, but these AI tools are extremely powerful. And so I downloaded these, but when I go to analysis and tools, I'm going to type in something, detect objects using deep learning. Okay, so when I go to image analysis, I have detect objects using deep learning. And I can access it a couple other ways here, because when I go to tools, toolboxes, image analysis, change detection, deep learning, look at all the different tools I have here. Classify objects using classify objects, detect objects. That's all I'm going to do, because we can classify them into different classes. And then some of the neat things we can start to do is train deep learning models, meaning, hey, here's a car, here's a car, here's a car, here's a car. You make a model based on what a car is. Now you can use RGB, and some of the things that we have with drones these days are what? We've got the infrared, we've got the thermal. So if it's got a certain thermal or infrared signature, in addition to the other bands, and also the actual shape of it, we can start to bring these into these models, and that would be great for someone else to do, because this is the project I'm going to talk about next with the USDA. And so using AutoDL, train deep learning model, like, hey, let me go pick out 10% of the cars and then figure out if we can identify the other 90% of the cars. Export. So we got about 10, 12 tools right here. And I bet you, and probably Juan can attest since he works out in the workforce, there are probably people here who just live in this space right here within image analysis. But we're just going to look at detect objects using deep learning here. And this stuff is so kind of up and coming that like Esri really doesn't have training for this yet. So there's not a lot of Esri training. The other thing we have, like Esri hubs, is another technology we get into. There's not a lot of training for Esri hubs right now, because it's just so cutting edge in the last 2 or 3 years that people haven't gotten around to creating training for it. And so a lot of it is you gotta figure it out on your own. So detect objects. What's the input raster? My input raster is going to be, I'm going to look just on one of these images right here. And what I'm going to do is I'm going to pick out the trees, because I know the trees worked already for December 2023. So for this image, I'm going to go and try to pick out all the trees based on this model. Now, this is a little problematic, because you can see these trees here have no leaves on them, where that I've got a couple of evergreens there on the side. But I'm just going to pick out this model here for December 2023. You're going to see the output, and then the model definition is going to be these DLPK files that we can download. So I'm going to click on week 11. I can click on tree detection. And the one thing that I ran into previously was when I ran this model definition, it did not like me. It asked me to install these new libraries. I finally did, and then it ran into some errors. These are all input parameters that it takes and lets me run. Then I can just click on the run button. So from this image, it is going to go and pick every single tree from this. Now this is going to be a lot harder than the cars, because the cars, they got a general size, shape, orientation, and then you can see when I run these, I'm at 0%, 2, 3. Now, to train some of these models, especially for like wildfires for Western United States, you're sitting here for hours. Me, I don't have the patience to sit for hours, but graduate students have the patience to sit for hours and do it. So I just, you all can, you all can go and do that. And so while this thing's running here, I'm going to show my idea for things, because one of the things about these models is that they're extremely proprietary. And so people don't like to give away their models, which I think is, yeah. Probably wouldn't give away my models. Have I talked about this idea with anyone yet or no? Okay. It's called swine lagoons. And now, do we know what a swine lagoon is in North Carolina? What's that? Swine, do we know what a swine lagoon? Yeah, we know what it is. You all should if you took geostats, right? Because we know where they are. They're in the eastern part of the state. We know Jones County. We ran spatial joins to count the number of swine lagoons by county, all that other good stuff. But what happened was we had someone from the Rachel Carson Institute show up. Rachel Carson, does anyone know who Rachel Carson is? Who is it, Alondra? Kinda. Is she still alive or no? Founder of something. David, you want to help her?
I can try, I don't know much more. I know she's the author of the book Silent Spring.
Yeah.
Which is like the basis for a lot of environmental. So many.
Yeah.
I know that it was like down in like coastal North Carolina, somewhere some of her work was done.
Yeah.
But yeah, I don't know much more.
Yeah, that's about it. It's kind of the founder of the environmental science movement in the late 50s and early 60s with, I think it was like DDT or something like that. I don't know that much about that side of it, but someone from the Rachel Carson Institute came, and now does anyone recognize this map right here? What's this look like? Here are all the swine lagoons from North Carolina 1 map. Here's another map here that has all the swine lagoons from the Department of Environmental Quality, and they're slightly different. But and when we zoom into these points right here, you can see the actual. Oh, this isn't the swine lagoon. This is the swine lagoon right here. And if I were to click on this point right here, is there anything that this point feature doesn't tell you that would be of interest to you? Tells me the number of lagoons. Is there anything interesting that these attributes don't tell you? What is something else that you would care about with that swine lagoon? The size of it. Size of it. Look at how unique that shape is, though. That shape is pretty cool looking. Not cool looking, but do we have naturally occurring lakes like that in North Carolina? No. And I don't know why they're built like that. Someone can explain that. But I zoom into these swine lagoons. This one looks a little bit smaller. It's got this kind of quadrilateral shape as well. I can click on it. It can tell me it's one swine lagoon. It's represented as a point. So obviously it doesn't have perimeter and it doesn't have area, even though I can look at it right here and there, thing has perimeter and area. And so my idea is let's identify the swine lagoons because we have varying data sets. One data set has 2,092. One data set has 2,107. So what's the authority, what's the difference between those? The second thing I also wanted to look at was how can we measure how much these things contribute to where's all this swine pig poo go? Groundwater. Where's the groundwater go? Into my well, you know? Right, into your well too. What's the key? Is there like a little boundary between? No. What happens when it floods in this part of the state? Where's all this stuff go? Everywhere, everywhere. And so I always thought it was interesting, and they kind of brought up this question as to, well, what's the total area of this? First of all, is it a swine lagoon? Yes or no? Second of all, what's the area of it that contributes to the, I don't know what the right word is, what word, to the environment, environment. I don't want to use the word environmental justice because that's kind of a no-no word these days, but how can we measure potential environmental impact? Because what is a big buzzword these days, especially in the state of North Carolina? Natural hazard, natural disaster. In the event of a natural hazard or a natural disaster, what is the potential impact of this on groundwater, transportation, lives, water quality, all these other things? Are people going to move back here with compromised water quality? We were in Puerto Rico. I guess it's still technically last month, where people are out of water for 3 weeks, out of electricity for 9 months. What is that really? What are the alternatives there? Now they're looking at solar panels, but what are the alternatives here? I don't want to be one of those folks who just say, well, let's get rid of all the swine lagoons, because guess what? Someone else is going to go make money off of swine lagoons, because the demand for swine, pigs, bacon, all that other stuff is not going to go down. So, how do we have a good idea of this? And so what I would like to do is put together a proposal, an AIML, detection tool, to detect all those swine lagoons, all those weird shapes, circular, and then how do we vet those from other things? Because we also have different types of imagery as well, available throughout the state, above and beyond visible light. I think we have some type of color infrared. Now this is North Carolina 1 map. We have imagery. Okay. And then this is NC1 map. This has got imagery from CIR. I don't know what CIR is, but I think it's color infrared. Someone correct me if I'm wrong here. And some of this stuff takes really, really long to load. Let's look at some of the CR. Some of this takes really. So this is some of that CIR stuff here from the 90s. I guess it's not very good. Oh yeah. Is this just pixelated, or? Wow. Some people might have some work cut out for them if this grant gets half this grant. Oh, here it is. Okay. What is this? Looks like Swan Lagoon. Why is it red? Are these Swan Lagoons red? This is false color imagery. What's the red mean? What's this red? We have a drone. We just bought a drone that makes images that look like this, in addition to true color. What's the red? Vegetation, healthy vegetation. It's kind of funny that the vegetation is really, really healthy around all the swine lagoons because it's very good fertilizer. So maybe, hey, there's another component here for the swine lagoons with the NIR, the near infrared with these things as well. What's that? Well, we could make these separate layers. I mean, not separate layers, but separate inputs, because you could have, I believe when we start to train these, we can say, hey, swine lagoon, swine lagoon, swine lagoon, swine lagoon on both of these images that superimpose. So there'll be a spatial component, a shape component, as well as what we call, radiometric or spectrum, I guess a spectral component as well. So my idea is to, hey, let's create a model, because when we go back to Living Atlas, I don't see any swine lagoon detection. No. I don't see any swine lagoon detection. And I think that would be useful. We love our, impermeable surfaces, let's get Alondra's parents, make sure they pay their extra $2.40, to Wake County or whatever. And so I like the idea of this model, and eventually it'd have to be open source, because even though we all know and love Esri, the world doesn't just know where, utilize Esri. We got QGIS and some of these other applications. And so let me go back to what I was running before, because hopefully it ran my little model here and it picked out the trees. So December 2023, it picked out the trees. Yeah, it has some here. It's got the little bushes right there. I like that. We picked out these right here, but a lot of incorrect things here. It did a good job right here. Okay, and let me just try one more time with the car detection. Let me see if that runs. Because it didn't run before. I just said, hey, you're running into some Stack Overflow issues and things like that. But it might not run for me here. Yep. So it ran into some issues here. When I ran it on my, ran it on my good computer, it was fine. But I do have a really good computer. It'll run this AI, ML, image detection. These things take a long time. And then, like I said before, there's a whole suite of tools here with deep learning, classify object, control points, extract features using AI models, POA, and this will make them a separate feature class. So I'll have to see what the difference is. But like this is the future right here for, future for everyone here. For homework. And then we'll take a quick break, and then we'll talk about the final with whoever's here, whoever needs to take it. And tomorrow I will mention who's turned in everything, who doesn't need to take the final, or it would behoove them not to take it. So for homework, exercise 10, this is going to be really easy because we've got so those folks from NASA, they created a couple of courses. One of them is in Fundamentals of Remote Sensing. One of them is in Fundamentals of Machine Learning. So basically, take one of the classes, show me that you finished. It might give you a little certificate, but Fundamentals of Remote Sensing, that guy with the beard, the young guy with the beard, he was the one who did this class. Yes. I think he's like 28 or something like that, and the other guy who was in charge was 33. Yes. And that could be all someday. I could be working for you all someday. This is the future. It's there to be taken. But do the little training right here. Take as many as you want. Like we have some neat things on like time series data, Earth observations. Just go through, do the little training, and show me that you finished. Take this online training, do the little online training, create the little username and password. One of them's for remote sensing. The other is for AI/ML. I would like you to, those of you who want to get into it, do both. Those of you who are like, hey, I'm here, I'm taking data science, do the introduction to remote sensing, because what we're looking at here with drones, and even to smaller extent, the GPS is what we call remote sensing, collection of data from a distance. You know, and this is just spatial data, but your drones these days are, you know, imagery, and here we're getting a multispectral stuff that our eyes can't see because there's so many wavelengths are out there that we just don't have access to that we do these days, which is really interesting. And I'm trying to get the thermal drone, but that's a whole different monster, not because we're dealing with IT issues there, but because thermal is what we call emitted. If I were to turn on the lights, could I see what color, and could I see what color his shirt was? No, because what's the ultimate light source out there? The lights and sun. Would I see him detecting, you know, giving away heat? Because it's emitted energy as opposed to reflected. Because most of the time, everything's reflected from lights or sun or whatever, where that thermal is emitted, given off, you know, and so those wavelengths are going to be slightly different. It's much longer wavelength. I think, what is that, Planck's law of black body radiation? I'm pretty good. I still got it, don't I? Oh, yes. So pretty. All right, good. All right. So all kidding aside, so just do one of these. I'll expect, and then next week we'll have the final. So those of you who already turned in everything, I'll just expect the project by next Tuesday. Give me a few days to grade it, and that should be it. And then that's it. You know, data science, nice little introduction on things. And so we'll wait here a couple minutes. I'll do a quick recording on the final exam. And if you did GERS, I don't need to see anyone. Let's go. No, I'm just kidding. No. Feel free to stay, talk here. But in a few minutes, I'll go through the final exam. So if you don't need to take the final, we're done. Yeah, thank you. Yeah. Thank you for letting me out early. No, we did enough here. The deep learning stuff is like, I know I ran it. It's just takes so much. Like, it's just so much computer space and this is just kind of cutting edge. You know, this thing is good computer. It'll never run on these unless you use tiny little chunks of, imagery. And so, do you know Barron?
Yeah.
Yeah, he was the one who went and collected all the drone imagery, which was pretty cool.
Oh, nice. So he's doing like that cemetery.
Yeah, he's doing the cemetery stuff with me, so. Well, we just got another cemetery today out in Bertie County and Greene County. So I've never heard of Greene County, but I knew Bertie County. But Greene County, because he's mix of African American and Native American. So there was a tribe out there that I guess moved up north in the 1700s, 1800s. So a lot of their ancient burial sites are here, where basically the African American and Native American had like group, you know. I think it's like called Tuscarora, which I think is real, pretty neat. So he's kind of very light skinned, which I thought was I don't know, there were like Native Americans in the eastern part of the state. I always thought of it with like Cherokee. So I look forward to that, and he's looking for some old schoolhouses, and so we'll bring out the drone and we'll bring out our GPR, and I've got to get that working and stuff. So that stuff's hard to figure out, hard to learn. Yeah, but and then I'm going out to Morganton in next month because someone else wants to do a cemetery mapping out there. So I'm not gonna argue. It's a good problem to have. People like your work, so.
Okay, and I talked with Dr. So he said he'd sign me up, so I think, is there anything you need?
No, I'll just start sending out announcements. And then that field day, we're gonna go collect data. That's gonna be Monday, the 12th.
Okay, yeah, I'll want to do that.
Yep. So in the morning, we're gonna go GPS. We're gonna divvy up the GPSs. GPS Okanochi, that mountain right there. And then go to lunch, and then we're gonna go down to that cemetery. and then bring the drone and the GPR and map part of that cemetery that we're working with.
Okay,
So that'll be cool.
yeah,
I think we'll have about 12 in that class.
okay.
Yeah. I look for, I would love to like go out west or western North Carolina and do like a field mapping class, but it's just, I think kids at our school are probably a little more limited by family obligations, jobs and things like that. And I would love to, but
Yeah, I cleared it with my bosses and all good, so I can.
who's your boss or the boss at home?
Well, both.
I'm glad you said that spot, and I'm sorry, I missed that part. So class needs starts on the 12th.
No, it starts on the 5th.
They feel-
5th, 6th, 7th, 8th, no class Friday because of graduation, and then the following week. But we'll probably just meet Monday, Tuesday, maybe even Wednesday to get the data off. And then we'll do presentations on Friday. You could do them here or virtually,
And that's 8 to 5 or
9 to 12.
12. Jeez, 9 to 12. Perfect. So I can literally do a half a day at the other spot if I need to. One.
Yeah, and I'll record, post online. The first day is introduction to GIS, tabular data, and then we'll do drones, GPS. 4th day, we'll get ready for the field trip. Like, hey, hey, you better make a feature class and all that, because I don't want to go back. I don't want any of you to go back, because I'm going to use this for a group paper for the class.
Some little paper as a class.
Yeah, yeah. Like, we got people that are, like, there's 12 authors on papers. You could do that. As long as I'm number one, that's all I care about.
Okay, that'll be fun. So my son, I think send him an email, but my goal is for both of us to be.
Okay, cool.
Trying-
I know teenagers.
I've been on it with.
Yeah.
Like, we both been here, and I just want to make sure I clear it.
Yeah. Yeah, you don't have to tell me how teenagers are.
Yes. So, yeah,
All right, you too. All right.
You don't need to.
Like a GIS.
So I like this. This. I want to say the most sense of travel.
Definitely makes sense in class. I know. The person is like,
Yeah.
I see it. Okay. I'll be in tomorrow. All right. Anyone joining us? I'll be back in a minute here. Talk about the final, and then we should be set. I can zip home, get my 1 hour drive home, and listen to the Mets or the Yankees. Okay. I'll be back in about 2 minutes here, but we're gonna be looking down here at the final exam. We'll be looking down here at the final exam, and I need to edit it real quick because I don't want people taking it. What's up? What's up, Andy?
Like during the meeting today, we talked about. You want to mute? During the meeting today, we talked about.
Yeah.
Sorry. During the meeting today, you talked about courses that we need to register for.
Yeah, you just need internships. That's all you need.
Okay, not so.
Oh, thesis, yeah, thesis. Let's get you presenting your thesis. When?
28th.
28th.
Schedule that, I said I was gonna send something to you on Wednesday.
Okay, do I have anything from you yet?
No, no, I'm gonna send it on Wednesday.
Okay, that'll be good. Yeah, because I want you to do a thesis.
Yes.
Cool, and then you'll sign up for just 3 credits of internship. Because you got all your credits, you got 30 right now, right?
Yeah, yeah.
Okay, cool.
And then, so that's for fall.
Yes.
3 credits of internship, not.
No. 3 credits of thesis, I'm sorry, I'm so used to saying the word internship. 3 credits of thesis, EASC 5,900. Alright,
I was gonna graduate in the summer. Like if I wanted to graduate in summer, what would I need to do?
sign up for 3 credits of thesis this summer. Do you want to graduate this summer?
I'm exploring something like an opportunity.
Okay. Like a job?
Yeah.
Okay, like, if you get a job, don't worry about me, Coke, all that other stuff. Get it, take it. Okay? I'll be a little disappointed that but I gotta find someone for Coke, but you getting a job is the most important thing. That's, I remember Samuel was like all worried, like, I can't go to school here anymore. I'm like, did you graduate? Yeah. You got a job at Esri, like, take it, please. Don't, yeah. So if a job works out, take it, finish it this summer, or, hey, just, work on it online and, you can, graduate remotely in December. Like, it's no big deal, get your feet wet. We got people doing stuff online all the time. Okay, so don't think twice about it. All right, everyone, I'll be back in a couple minutes, talk about the final, and then we'll release. Where's this at? Where are you looking? Okay, okay. Please, girl, do you want to need a place to rent? I have a basement, I don't know where it is, basement, I'll only charge you like 650, 700, separate insurance, I'm just kidding, I'm gonna get it. Well, where's it at? It's like, no, like, is it for the city or somewhere else?
So, private, so.
Okay. So, and you already spoke to them and things like that?
That's what it's, yeah.
Cool. Good. Did they do GIS stuff at all, or? Yeah, oh, so you know that? Cool, take it, yes. Greensboro, we can go hang out, I guess at all the places I hang out. Nice little town.
It's a little more expensive.
No, it's not. It's cheap. Cheaper than.
Yeah. It's the drum blowing out.
Once a lot thing about moving over. I was. 12 years ago. Just stay there. We do have a basement that's not being rented out. We need a temporary.
Based on how the whole process goes, Darlene.
Okay, yeah. So let it go here, no, get it? Okay, I'm back here. I'm gonna go through the final, just do a quick recording here. All right, how many? Why is Juan here? You taking the final one?
No.
You just want to hang out? Okay.
Yeah. I was going to ask you something later, but I can wait.
Okay. All right. Kimberly, are you taking the final? Or Gray, are you taking the final?
I was going to say, yes, I am.
Okay. All right.
I
All right.
submitted the poster I did for GERS, but
So you don't need to take the final.
okay. Okay.
All right. Let me make sure I've got the GERS here. Okay. Kimberly, this will be easy. There's a couple other people who are not joining us, or I don't know what their deal is. But final exam is going to be 50 points. So it's going to be 5 questions here. And we're going to just write some programs here. So each question's going to be worth 10 points. We're going to write some small basic programs. They're going to look a lot like this. So 2 of them are going to be about small basic. 2 of them are going to be about Python. 1 will be about open science. The first one says write a small basic program that asks the user for 3 numbers, gives the average of them, tells the users the highest, the lowest. So you're going to just write some small basic code that does that essentially. So remember now I got to remember it myself, but remember the read line, write line. So you read in a number or read number or whatever it was called, but read number. So you take in, A, B, and C, figure out what the highest is, figure out what the lowest is, figure out what the average is. Because remember how we calculate average, A plus B plus C divided by 3, that, total divided by the numbers. So you're just going to write a program, submit the code that does that. Next one, you're going to write a small basic program. Now we're going to do some loops. Using a loop, ask for exactly 10 numbers, outputs the average of the 10 numbers, the highest of the 10 numbers, the lowest of the 10 numbers. Now, kind of a coincidence? No. So you're going to utilize the code that you did in the first question for the highest and the lowest, put that into a type of for loop so that you can do the same exact thing. Now, I bet you the second question working with 10 numbers is probably going to have less lines of programming than the first question because we're going to put all these in a loop. So you don't want to have to check for the highest only once, 10 times as we run through the loop. So does that feel good, Kimberly? Okay, good. All right. I know you get some other things going on today, so I want to make sure we get this here. 300 words. What is open science? How does it apply to FAIR principles? And give me an example of each concept of FAIR. So first of all, what does FAIR mean? Give me what the F stands for. What is an example of something that's an F, an A, an I, and an R? So look up what FAIR principles mean. Talk about some of the examples that we discussed in class. Next question, write a Python program. Ask the user for 3 numbers. They can just be parameters from your tool. So we can do these in ArcGIS Pro. Outputs the average of the 3 numbers, tells the highest and the lowest. And we can run these in ArcGIS Pro. So we can just have text box 1, text box 2, text box 3, and then these can be input parameters as we run those. Because remember, we would do input parameters X times Y. And the last one we're going to do is we're just going to download this thing. And now we're going to interact specifically with ArcGIS Pro Maps, where the previous question, all we did was we can just create toolboxes that do something. Now for the final exam, all we're going to do is You're gonna open up a database, you're gonna loop through the database, and same thing that we just did before. Now, instead of looking at numbers that are typed in, we're gonna actually look at the feature classes. And remember, we've got previous code that just loops through all the feature classes, but this time you're gonna look at the number of features, count features, find which one has total number, the most number of features, the least number of features, and then averages the number of features from all the features that do I have here. I've got 1, 2, 3 features. So you're going to write a program that adds up the total number of schools versus time zones versus trails and adds all of those up, because you can add them all up, but do we really want to, who wants to do that? Who wants to open up the attribute tables and do this? Not me. So you're going to do that. Everyone feeling good about that one?
Yeah, sounds good.
Okay, all right. Hope you'll, and let me know if you need more time for anything. All right, Kimberly?
Will do. Thank you so much.
All right, see you later. You all have a good day.
You
All right,
too.
see ya, good night.